when we're dealing with growth, the amount or the total is equal to the initial amount times 1 plus the rate raised to the time. So my initial amount is $500,000. 1 plus a rate of 6%, and I'm raising that to the 8th power. So essentially my number is going to be this. That's what you can type right into your calculator. Okay? You can type it like that, or you can do 1.06 to the 8th power. Remember, we've got to do the exponent first. So 1.06 to the 8th times 500,000, and I believe your new amount's going to be $796,924.04. Same formula. The amount equals the initial amount, 1 plus r to the t. The difference is the amount is $675,697 equals I. 1 plus my rate of 02 to the 6th power. 675,697 I times 1.02 to the 6th. And now to solve for my I, I'm dividing by 1.02 to the 6th power. We can do it all at once. My advice to you, when you plug this into the calculator, I'm going to do 675,697 divided by, put it in parentheses, 1.02 to the 6th power. And when you're done, you should get something very close to $600,000. We have the amount, I, the initial amount, 1 minus r to the t. My initial amount was 200,000 cases, but it's going down at a rate of 0.42 or 42%, raised to the 5th power. So the A equals 200,000 times 0.58 to the 5th power. And now when I put that into my calculator, 0.85 to the 5th, okay, times 200,000, now these are my cases, 13,127.14. Once again, if you just did 13,127, that's fine too. Please slow down as much. This year there were 22,383 cases, but over the last 7 years, over the last 8 years, it's been going down at a rate of 7%. I need to put a question in here. What was the amount of cases, amount of flu cases 8 years ago? That's essentially what I'm asking here, so you can add that to your review. So, I ended up with 22,383 cases. Okay. My initial amount, which went down by 7% per 8 years. I'm just putting the numbers into the formula. The original formula, if you want to write it again, the total amount is the initial amount, 1 minus r to the t. When you put those numbers in, 22,383 equals I times 0.93 to the 8th power. And my I, 0.93 to the 8th equals I. Write that 8 a little neater. My answer is going to be 40,000. Or something very close to that number. When we compound something more than daily, the amount is going to be the initial amount times 1 plus the rate over n raised to the n times t. We're not going to compound with decay. You only have to worry about compounding with growth for our test. Here we're literally just plugging the numbers in. So I'm going to plug the numbers in for the first three here. Okay. Here I'm getting 20,000 times 1 plus. My rate is 7%. That doesn't change. But semi-annually means the n is 2. We're dealing with 4 years, so 4 times 2. Okay. That's what you're plugging into your calculator. The order I would go in is this. And I'll actually pull a calculator and do it with you on the first one. I would do it this for the calculator. If you can put it all in at once and get the right answer, awesome. You're good with that? Great. But if you can't, this is what I would do. 0.07 divided by 2, hit enter. Add 1, hit enter. Raise that. I would do the exponent in my head or off to the side. 4 times 2 is 8, so I'm raising that to the 8th power. And then the last thing I'm going to do is multiply by 20,000. And I'm going to get $26,336.18. Now, the more often you compound, the bigger your answer should be. So when I do quarterly, I should get a slightly bigger answer. 20,000 times 1 plus 0.07, we're now dividing by 4, but it's 4 times 4. So we're going to do 0.07 divided by 4. I'm going to add that to 1. I'm going to raise that to the 16th power now. That's 1.3199. And multiply by 20,000. Do not round anything. That gives me an answer of 26,398.59. Once again, a little bigger. When you compound daily, we should know there's 365 days in a year. 1 plus 0.07 divided by 365. That's going to be a pretty low number. 4 times 365. These we're still doing it over 4 years. So in my calculator, I'm going to go 0.07 divided by 365. That might give me a number with an E on it. Doesn't matter. Whatever it is, don't round it. Add 1 to it. And now we're going to raise that to 4 times 365. You might not be able to do that in your head. So I would do raise that answer to parentheses 4 times 365. You'll get an answer of 1.323. And then I multiply by 20,000. And I get 26,461.89. Rule of thumb. With the E's, we're just following our basic rules. You have the same base, we're adding. That's the answer. You have the same base, you're subtracting. That right there is a big part of the answer. 40 over 12 reduces to 8 over 3. That's the answer. Here, the 3 needs to go to both terms. So this really becomes 5 cubed and e to the negative 30x. We should know a negative exponent goes to the denominator. 5 cubed is 125 over e to the 30x. The square root of 121 is 11. Anytime we raise something to an exponent, we divide by the index. 10x divided by 2 is 5x. So e to the 5x. And there's your answer. Instead of redoing the video, sorry guys, we're going to have to correct this. 40 divided by 4 is 10. You may have caught that mistake earlier. Hopefully you see it now. So that answer should be 10e to the 7th over 3, not 8e to the 7th over 3. Hopefully you see my mistake and are able to correct it. If you're being asked about something that's compounding continuously, the amount A is equal to, we call it the principal P instead of initial amount. but the principal e raised to the rate times time. This we are straight up plugging into our calculator. 10,000 times e, the rate is 6% over 3 years. So essentially I'm doing 10,000 times e raised to the 0.18. When you type that into your calculator, you're going to get 11,972.17. What's my asymptote? Because there's no zero over here. The asymptote line is going to be y equals 0. Domain's going to be negative infinity to infinity. My horizontal asymptote is going to be y equals 0. Domain, I can put whatever I want in for x. My horizontal asymptote is going to be y equals 0. Now when I go to graph it, my key point, Kp, if you plug 0 in for your t, you're going to get 2. E to the 0 is 1, 1 times 2, so the key point is 0, 2 here. Here, you plug 0 in for your t, you get 3. E to the 0 is 1, 1 times 3 is 3. So 0, 2, 0, 3. Those are your only points. When you graph a negative exponent, means you're going this way. It approaches infinity as x goes to infinity. With a negative exponent, your y, stay there. Your y goes to 0, or let me rephrase. When you have a negative exponent, you approach the asymptote as x goes to infinity. When you have a positive exponent, you approach the asymptote as you go to negative infinity. That needs to be studied. Okay? All right.